this video, we will talk about how to find a basis for a column space of a matrix. So there are 3 steps we need to do. First, we have to convert the matrix to row echelon form. Second, we need to identify the columns with pivot entries once it's actually in row echelon form. And the last step is the corresponding columns in the original matrix are the ones that form a basis for the column space. So let's check out an example. Let's say we have matrix A here, and we want to know how can we find a basis for the column space of this matrix? Well, first we need to convert this matrix to row echelon form. So in the first row, our first non-zero value, which is our pivot entry right here, is this 1. And remember, in row echelon form, a matrix has all zeros below the pivot entries. So this 1 and this 3, these both need to become zeros. So how could we do that? Well, we could say row 2 can just become row 2 minus row 1, because that would be 1 minus 1. So that would get a 0 right here. And then we can say row 3 can just become row 3 minus 3 times row 1, because that would be 3 minus 3 times 1, which would be 3 minus 3, which would make a 0 right here. So let's do both of those steps. So the first row is not going to change at all. We'll just rewrite those values. All right, the second row will be row 2 minus row 1. So 1 minus 1, that's 0. 3 minus 2 is 1. 6 minus 1 is 5. 0 minus 3 is negative 3, and 2 minus 2 is 0. And then row 3 we said is going to become row 3 minus 3 times row 1. So we get 3 minus 3 times 1, that's 0. 7 minus 3 times 2, so 3 times 2 is 6, so 7 minus 6 is 1. 8 minus 3 times 1, that's 8 minus 3, which is 5. 6 minus 3 times 3, so that's 9, so 6 minus 9 is negative 3. And 6 minus 3 times 2. So 6 minus 6 is 0. Okay, so here's our first pivot entry. Here's our second pivot entry. We need to make this value a 0 below this second pivot entry. So notice we could just do row 3. We can say that can become row 3 minus row 2, because that would be 1 minus 1, which would give us a 0 right here. So let's do that. So our matrix becomes row 1 doesn't change at all. We'll just rewrite those values. Row 2 also doesn't change at all, so we'll rewrite those values. And in row 3 we get 0 minus 0, that's 0. 1 minus 1 is 0. 5 minus 5 is 0. Negative 3 minus a negative 3 is negative 3 plus 3, which is 0. And 0 minus 0 is 0. So this matrix is now in row echelon form. REF, row echelon form. And what we need to do, remember step 2, is identify the columns with the pivot entries. So here's our first pivot entry, the first non-zero value in the first row. And here's our second pivot entry. And notice there are no pivot entries in this last row. So these are the only 2 pivot entries we have. So the columns that correspond with these columns that have pivot entries in the original matrix form the basis for the column space. So in other words, the first column and the second column of the original matrix form the basis. So it's going to be these values right here. So what we can say as our final answer is the basis of the column space of A is going to be equal to this first column, so 1, 1, 3, and the second column, 2, 3, 7. These 2 columns form a basis for the column space of matrix A. And you can use this exact same process to find a basis for a column space of any matrix.